Welcome, welcome. All right. So, guys, I'm sure you already know Dr. Kevin. He's a professor of computer science at UBC. Today, he will be talking to us about AI research for socioeconomic development, social good, a bit of reinforcement learning, and game theory. That's like the topic area. But I promise you guys, you're going to have a lovely session, a lovely time listening to him today. So, without much ado, Dr. Kevin, over to you, please.
Thanks. I see that I don't have permission to turn on my camera or to share video, so we need to do that.
Okay, yes, I would correct that now. All panelists. Okay, so you have the permission to share the video now, and you should be able to share your screen. Okay, can you please try sharing your screen again?
Yeah, that looks like it's going to work. There we go.
Great, it's up now.
And let's get some video too.
Yeah. Should be able to share video.
No, I still can't share video.
Whoa. Why is that the case? Let me see. General. Copy. Quite strange. Looks like it's enabled here.
I cannot start my video because the host has stopped it. That's what it says.
Okay, so just set. Let me see if I can get it. And I can show video. Okay, so this is what I'll do. I would let me see if I can promote you to okay, good. Make host. I think that's what I should do. Okay, please try it now. Aha.
There we go.
Yeah. Good to see you.
Good.
Yeah.
I love the feeling of power. All right. Wow, great. Okay, well then let me begin. Let's see, we've got how many of you? Almost 200 people here. I'm so happy to have the chance to address you. I enjoyed seeing a few moments of that video at the beginning because it was cool to see some pictures of Nigeria. I've spent a bunch of time in Africa, but none in West Africa. So I hope someday to visit you in person. I guess when I was invited to do this, I thought this was going to be a chance to actually come to Nigeria and finally see it. And that didn't work out, but I'm happy to be with you in spirit. And let me also say I'm so sorry about the terrible events in Nigeria that led to the postponement of this lecture. I hope everyone is safe and that things have stabilized. I guess in the news here, I hear that things are better than they were, but as you might imagine, the news here is focused less on Nigeria than it is on whether Donald Trump is going to finally accept reality. So today I'm going to speak about the topic of AI for social impact. And what I'd really like to think about, I'm going to talk about two different projects that I've done, one of which involves agriculture in Uganda, one of which involves food banks in North America. And I'll tell you a little bit about those specific projects, but I recognize this is a broad audience. The specific kind of AI methodologies that I'm going to talk about won't be ones that everyone knows about. So some of you might be excited about the technical details, some of you less so. But more broadly at the same time, I'd also like to talk about just the general idea of what it means to try to make an impact with a piece of academic work, and what lessons I think I've come to understand about how a research project can be impactful and how people can embark upon impactful social work in a deliberate way. So the work that I'm going to speak about uses market design as its kind of methodological hammer, because that's kind of the way that I look at the world. This is a cutting edge and quite transformative methodology in economics and computer science. Actually, a close collaborator of mine working in this space just got the Nobel Prize in economics about a month ago. So this is something that right now the world is really excited about. And so this is going to be the way that the kind of theme that cuts through this lecture, the way that I approach these social impact problems. But I think the things that I'm going to have to say are going to be broader than this particular methodology. So if you're not somebody who has previously worked in market design, what does this mean? Well, you might think of a market as a place where you go to buy a tomato, but more broadly, a market is a kind of mathematical structure for thinking about how to allocate scarce resources when you've got a bunch of self-interested people who each have a desire for these scarce resources, where information about who values what is not available centrally, but every individual market participant has their own private information about what they value. And the designer of the market cares about the good. So they care about bringing about good social outcomes, even though they don't know what is good because they don't know who values what. And computer science and artificial intelligence didn't used to be a big part of the story of market design. Market design really used to be a kind of area within economic theory, within microeconomics. But in the last kind of couple of decades, computer science has become a really core part of the market design toolbox. And the reason is, and so this has meant that computer science needs to be involved. I guess furthermore, the existence of past data about behavior in markets means that data science and artificial intelligence have a key role to play. So that's where I'm coming from with market design. I guess I should incidentally say I would welcome interruptions and questions throughout the talk. I think this would be a lot more fun if it was an interactive discussion than if it was me talking by myself for an hour. So I guess I can't easily see the chat, but I welcome you to ask questions in the chat, which maybe the moderator can burst in, or if you're feeling particularly brave, you could just come in. So I could even now take a comment if anyone has one, or else I'll proceed. Somebody's going to have to be the brave first person to go. Let's see. Somebody's saying, please use the Q&A. Got it. And by that you mean, I think the questions at the end, or the chat? I'm not sure. Anyway, I'll proceed. So the first project that I want to tell you about is a project on allocating donated food among food banks. This is a project with Taylor Lundy, who's a graduate student at the University of British Columbia, Hufu, who's a colleague of mine at UBC, Scott Commoners, who's an economist at the Harvard Business School, and Alex Way, who's a student of his. So here's the setup. Large donations of food are periodically given to centralized food banks, which are kind of institutions in North America that collect donated food, and then they redistribute this food to local subsidiaries called food pantries, which are community organizations that give food to people in need who maybe have lost their job or maybe just live paycheck to paycheck and are food insecure. And so these food pantries are distributed across a large geographical area like a country, and they experience different levels of demand based on local conditions, like a natural disaster or an economic dislocation in a particular area. So in order to think about how food banks ought to, oh, cool, I see. Yeah, please go ahead. If somebody wants to just speak up anytime I pause, I'm happy to take a question.
Oh, okay, great. Thank you very much. Okay, so there's a question here from Onwuka Daniel. It says that when you mean market design, does it also detail knowing what the people want before creating a solution for them? Does
Great
market?
question. Thanks for the question. I think but definitely not, Daniel. I think a market design is really about saying, there are things I don't know about what people want. If I really knew what people wanted, I would just give it to them, right? I would just sort of have a planning problem. If I know that everybody wants to take the shortest path, I would just run a traveling salesman problem, right? Like, I would just have an optimization problem. Market design says people need to tell me what they want, and then I'm going to get a bunch of reports from people saying what they want, and I want to put these reports together to try to figure out what would be a socially good outcome based on these declarations of demand. And something that is often, but not always, a characteristic of a market design problem is that I'm going to impose payments on people. So people will say, here's how much I want things, and the amount of demand might be expressed in monetary terms. So I might say, I would pay $100 for this painting, and you might say, I would pay $60 for the painting. And so a market might then say, okay, Kevin wins the painting, and he's going to have to pay $60 because $60 was the second highest price. I would have had to pay $60 to outbid Daniel. So that's the price that will be imposed on me. So often, in a market, you say sort of how much, what you want, how much you want it, and then an outcome gets determined by the market. And the outcome might not be, anyone's bid. It might be some computation of people's bids. But the only sense in which we're going to decide in advance what people want is when we think about what kinds of bids we're allowed to say. So if I wanted to say something like, I want the painting, but only if you'll also give me a museum in which I could display the painting, my bid didn't allow me to say that kind of only if statement. It only allowed me to bid on the painting. I had to go buy the museum separately. So if I have these kinds of complex preferences, then I need to understand that in advance and set up a market that allows them. So not all markets involve money. One market that has gotten a lot of attention is a market for kidney donation, where I can say, I'm willing to donate my kidney, but only if my relative who has an incompatible need for a kidney has a donation from somebody else. So you can get these chain donations. So that's a market. It's a market that doesn't involve money. It's motivated entirely by social good. That's maybe another example of how market design can be used for social good. We're going to be here thinking about it in the context of food donation, but definitely we approach market design from the perspective of thinking of people having to tell us something about what they want. Any other questions, or should I continue at this point?
Great. Please continue at this point. Thank you very much.
Thanks. I'll sort of try to keep an eye on the chat, but it's hard for me to see it when I'm sharing full screen. So please just go ahead and burst in if there's something else. Okay, so we come kind of essentially to the point that Daniel raised here. The food bank needs to ask food pantries to report their demand in order to make this allocation, in order to do a good job of allocating food globally. And although these food pantries are each charities, they have an incentive to over-report because they care more about their own local communities than they care about the broader, the broader good. Every pantry is a advocate for its own community, and so it might tend to err on the side of requesting food that it might need, and this can cause a bad global allocations of food. So we might want to think about how to best incentivize the food pantries to allocate food in a globally useful way. So if I look at this through the lens of market design, this is the setting with stochastic demand. So agents know their probability of needing food today, which I'll call their type. That's their private information that they know and the market designer doesn't. Then this demand is realized, and the center knows, so when I say that the probability is realized, they know the probability, but they don't know each day whether they're going to need the food or just what the probability was. The center doesn't even know the setting, the probabilities. It just knows the distributions from which these probabilities came. And the food banks want the food to be used efficiently. They want the food to be sent to the places where the probabilities of needing food are the highest. The food pantries are, at least to some extent, strategic in the sense that they would prefer to have needed food come to them than to go to somebody else, all things being equal. They're still charities. They still would like to see food going to needy people, but they would particularly like to see food going to their own needy people. So if we try to model this as a market design problem, here are a couple of ideas. First of all, we can see it as a utility maximization problem, where as the designer, we would like to maximize the efficiency, the value of the allocation, minus the payments collected. So if I was to make the food pantries pay the market designer, I would like these payments to be as small as possible, because the market designer here is not looking to make money. They're looking to use the payments simply to cause the reporting to be honest. This turns out to be a relatively unstudied problem in economics. Most literature in market design ignores payments and simply says, I want to maximize efficiency, and I just want to use whatever payments it takes to get efficiency. The second idea is a little bit more profound. In the charitable setting, it's often the case that you have the ability to audit the recipients of a charitable donation. So you're often able to go to a food pantry and say, you told me you needed food. Did you in fact give away food? Did you turn out to need it, or did you not? Whereas if you tell me the food and I don't give you anything, then I don't get to audit you. This auditing is kind of only one-sided. I'm only able to audit you if you actually claimed that you had a demand. And this is going to turn out to be powerful in the market design setting, and it turns out to be useful because charities kind of have this property of being audited anyway. So in terms of this, looking at it, the stochastic demand setup, this does seem like a market design problem. This seems like the kind of thing that this market design hammer that I told you about might be applicable to. So, a bunch of us who think about market design theory looked at this problem, and we came up with a key result on the problem of unit demand. So unit demand is the restricted case where we model all food as being one kind of thing, and agents either need a food allocation or they don't. So we say that agents get no utility for consuming an allocation they don't need. So imagine that I'm allocating perishable food, and if you get allocated food and your community doesn't need food that day, then the food spoils and you have to throw it out. And there's no way of specifying quantity, so you just get an allocation or you don't. So in this setting, we came up with what we call waste not, pay not mechanisms. And the actual exposition of this is quite mathematical, but let me give you the gist. These mechanisms work by saying, when I allocate food to a food pantry, I'm going to audit them. I'll only charge them when agents were allocated and they didn't need the allocation. So if you get allocated food, you'll be audited. If I find that you really did need the food, then you get it for free. And if you needed the food and if you claim that you needed the food but you didn't need it, then I'll make you a payment. If I use this kind of a mechanism that has this property in combination with a second price auction, then a second price auction, for those of you who know a little bit of economic theory, is an efficient mechanism. And this is still efficient, but has lower payments. So the payments are going to be scaled by some factor less than one. It's going to depend on the second highest type. We derive this using a classic mechanism design tool, which is Meyerson's characterization. And the upshot is we get the same allocation and a smaller payment. So the so-called revenue equivalence theorem doesn't apply to us here. And we can apply the same idea of this sort of waste not, pay not transformation to any mechanism that has payments. And we can thereby construct a provably optimal auditing mechanism, which intuitively is sort of a blend between second price auctions and lotteries. So for some valuation distributions, we'll just randomize. We're not going to do payments at all. So if that didn't make sense to you, don't worry about it. We did a little piece of economic theory here. We then started thinking about generalizing this, and we said, What about the case of multi-unit demand? You know, it's obviously not the case that every food pantry has exactly the same degree of demand. All shipments of food are the same size. How would we think about a case where you have to actually report a level of demand? So you might say, my demand today is big, my demand tomorrow is small, but it's not zero. Well, here we run into trouble because the optimal multi-unit demand utility maximizing mechanism is not even known. We're already getting to a place where economic theory, we're hitting up to the boundaries of what's known in economic theory before we even think about this auditing problem and this specific application of food pantries. But there's a widely known mechanism called the Vickrey-Clark-Groves mechanism, which is optimal for efficiency, not for utility maximization. But it's pretty good for efficiency maximization. So we showed how we can combine this waste not, pay not idea with VCG and achieve higher utility, albeit without a proof of optimality. And the other thing we thought about is really we would like to get away from the idea of using money here. Food pantries don't actually pay food banks for their food. It just gets donated. You might remember we just added the idea of using monetary payments as a way of creating good incentives to report. But this might be a deal breaker for food pantries because really they're charities. They have money, but not very much. And indeed, often the ones with the least money might be the ones with the greatest demand for food. So this really might not make much sense. So it turns out we can use an idea called dynamic mechanism design that replaces payments with punishments. So we can say, in January, you make a report, and if you turned out to request food that you didn't need, then maybe in February, we won't allow you to participate in the mechanism. We'll make you sit out around, and somebody else will get allocated, then you'll come back in. So I'll use the ability to threaten you with future opportunities to participate in the mechanism as a replacement for payments. And that we showed how you could do that. So that's all I want to say about how these mechanisms work. Let's step back. So we modeled some core issues that arise in the interaction between food banks and food pantries. We thought about stochastic demand, utility maximization instead of payment minimization, and the ability to audit consumption. In response, we did some meaningful new economic theory, and we published it in a place that cares about economic theory. And we had some interesting conversations with food banks, but they're not yet beating down our door. There are a few reasons why. They sell more than one kind of food. So everything I've told you about here is really about just allocating sort of homogeneous food. There are often combinatorial preferences. So there might be a couple of kinds of food where if you get more of one, then you need less of another one. There might also be complements, like, when I get more of one kind of food, I also want more of a second kind of food. So I want these, if I'm going to bother opening my office at all, I want to make sure I've stocked the shelves enough. So if I have these kinds of combinatorial preferences, I can't express them in this bidding language. And finally, maybe the core problem that we addressed here really wasn't the main problem. Maybe fairness or limiting waste might overwhelm people's concerns about incentives. So maybe these kinds of incentives issues just aren't going to motivate the food banks as the main thing they should think about. So I'm going to come back to this kind of pro and con evaluation at the end of the talk. Before I do, I want to shift and talk about a second topic. So this might be a good time to take questions on this first topic about food banks. Any questions from anyone, or should we go on? I see a question. Oh,
Yeah.
I had the wrong window open. I didn't realize there was a Q&A window. Okay, so I see somebody say, kindly elaborate on the stochastic demand.
Exactly.
Pardon me? Sorry, I heard somebody speak, but there was a delay. So stochastic demand means that the bidders themselves don't know for sure whether they need food, right? So if you're a food pantry and you're making a report to the food bank saying what your need is going to be, it isn't like you've got a bunch of customers just standing, waiting in your office, hungry, saying, hey, we're hungry, we want food. And at that point, a truck, ships across the country with some food and comes to you while everybody waits. You have to forecast, right? So if you're a food pantry, you say, it seems to us, based on all of the things we know about our community, that next week we're going to need some food. So please ship us some food. And then the food comes, and then you say, people turned out not to need food as much as we thought. Sorry about that. We're going to waste some food. So that's what we mean about stochastic demand. The food pantries have better information about their local communities than the centralized authorities do, but they don't have perfect information because the demand comes and goes. Great question. Anyone else? Am I supposed to say that it was answered live? There we go. That was done. Cool. Well, then let me go on. So I'm going to shift now to talking about a problem of agricultural market. Somebody's saying I'm speaking too fast. Sorry about that. I'll do my best. Agricultural market inefficiency in Uganda. This is a problem that I worked on in collaboration, particularly with Richard Setrabule and John Quinn at Makerere University in Uganda. Neil Newman is a PhD student of mine at UBC who I worked closely with. And then Lauren Berquist, Brendan Lucier, Craig McIntosh, and Nicola Merlika are colleagues of mine at Microsoft Research, Berkeley, and University of California, Los Angeles, who we all worked on this project in various combinations. So let me tell you about this problem. So I've given this conversation, the same talk to people in North America a couple of times, but I like that this whole talk is about food insecurity, and it begins with food insecurity in North America before moving to food insecurity in Africa. This is a problem that happens all around the world, but now let me talk about what I've learned about how this manifests in Uganda. Some of you might understand local conditions better than I do, and want to comment about what this looks like in Nigeria. But what I learned in the kind of half year that I spent living in Uganda is that subsistence agriculture is one of the main occupations that people have in Uganda. And buyers and sellers have a lot of trouble finding each other. Farmers waste a lot of time harvesting and transporting produce that they might not yet be ready to sell, and it sometimes spoils if they harvest and aren't able to find a buyer at the right time. And when Richard and John and I did an analysis of prices, historical prices in Uganda for some staple crops across time and across space, we found robust arbitrage opportunities where people could historically in the data have, say, bought beans in one town and then rented a truck and paid a driver and shipped from one town to another town and sold at the prevailing prices in the second town and consistently made money. Or they could have harvested maize and paid somebody to dry it and put it in a storage space and rented the storage space, paid for fumigation, and sold it 4 months later and consistently made money. And the fact that we were able to find these arbitrage opportunities across space and across time showed us not only that maybe we had a good idea for how to make money, but also that the market wasn't behaving properly. Because if the market surfaced enough information about prices in the market, about people's supply and demand, then these arbitrage opportunities ought to go away. Then entrepreneurs ought to do this arbitrage, and then prices should sort of even out. So the fact that that we saw these price disparities told us that the market wasn't doing its job of surfacing information about what supply and demand were in the market. By the way, all the pictures in this section are pictures that I took myself, and they might look similar to scenes that you've seen in Nigeria. So, and some of these pictures are relatively old. I think the picture on the left here I took in maybe 2011. But when I've been back to Uganda more recently, many of them haven't changed too much. So the farmers in the villages often have relatively low tech lifestyles. They might not be using modern agricultural techniques, but even so, they tend to have mobile phones, so they're able to be connected to the central areas. Central areas are much more developed, and the guy you see here on the right is a trader. So this is a farmer who produces maize out in the rural areas. And here's a trader who's buying large quantities of maize and milling it and selling it to industrial clients. So what we landed upon was an electronic marketplace called Kudu, which was designed to allow farmers who only had feature phones to make bids to sell agricultural commodities that they produced that would consider price, quantity, and geographic location. Then we performed matching, and we would give price alerts by SMS and also by a USSD. So we began when we first launched this system. I guess we started the work in 2011, and we first went live in 2013 with an automated matching where, first of all, we did a greedy algorithm, and eventually we did the right thing. We used a maximum weighted bipartite matching algorithm to decide which farmers to match up with buyers and at which prices to do the matchings. And we ran a limited trial where we did small scale radio ads. We had a student helping to respond to SMS messages that came in malformed, and we did a bit of outreach to buyers where we had some people go around to the markets in Uganda and Kampala and get some buyers to participate in the market. And you can see from this graph, we got a bunch of people to participate. At our peak, we had maybe 250, 300 people participating in the market in 1 month. And then we ran out of money to run radio ads and things kind of tapered off. And between 2015 and 2018, we did a reboot where we were approached by a team from California and aided by a team from Microsoft Research to do a larger scale study of this Kudu idea. So we worked together with a couple of organizations in Uganda. So AgriNet is an outreach organization that already existed in Uganda that tries to help connect farmers with the marketing services. And IPA was a sort of project management group in Kampala. So they had an arrangement where they had a group of agricultural outreach workers who you see here in the bottom left, along with us. You can tell the Mzungus are the people who are not agricultural outreach workers. This was the research team, and we met with all of them. But they would sort of be embedded in different communities, and they would kind of educate farmers about these the market and how to access financing and how to get transport for their crops. And then in the bottom right, we had a call center that was a way that all of these agricultural outreach workers and potential sellers could phone in, and they would sort of broker trades and help people figure out what might be a good trade. So we sort of built everything on a larger scale, had sort of more money to do all of this marketing, and we ended up running a market substantially larger than we did before, where we had sort of tens of thousands of registered users, quite a lot of activity over a couple of years. And we actually had the funding to be able to verify whether trades really happened. So we would phone people up and say, we brokered a maize trade between you and some seller. Did they actually have maize? Did you physically drive there? Did they actually give you the maize? What price did you in fact trade at? And if they said yes, we really did trade, then we would record the trade. And so here's what actually happened. So about half of our trades were in maize, and then there was a long tail of trade in other crops: soya, rice, beans, and some other crops. The trade happened all over Uganda. So much of it was people trading in the same city. The buyer and the sellers were less than 25 kilometers apart, and you can't really see them on the map. But much of the trade was long distance across the whole country. So we would really find somebody in Kampala who wanted to buy something, and somebody else in Gulu who had it to sell, and you actually have to drive the length of the country to go make the trade. That was encouraging to us because this really was this kind of arbitrage that we'd found in the data, that there really was matchmaking that made sense to do across long distances. The way that our deal coordinators did the matching was this kind of horrible database interface. So which is what they wanted. We really tried to push them towards something else, but they just sort of had this this list of everything that was going on. Here I blurred out the seller names, but otherwise this was live data. So you could see the district and the sub-county and the parish and how much they were asking for and what the price was, how long the ask had been in the system, and bidders and what they had, where they were and what they wanted. And when you saw something that looked like a potential mask, you could then drill in and see some phone numbers, which we've blanked out here. And then you could actually click on it and make a phone call and leave a note saying, this person wants to, confirms they want the bid, or these people say you should call back. And so, it was this laborious manual process of assembling trades together. And why did it have to be so laborious? What kinds of challenges did we encounter? So we went out to the villages and did this kind of training. So here you see a couple of our deal coordinators out in the village, along with kind of Neil sitting in a chair at the front. Neil was the grad student of mine who built this system. You see that one of the deal coordinators has a T-shirt that explains how to use Kudu, and the other deal coordinator is explaining it. And there's clearly a demand. All of these farmers from the surrounding areas kind of showed up and were interested in learning about Kudu. On the left here, you see the interface on USSD. You can see the very first thing it asks is, which language do you want to use the system in? Because there are a variety of different languages in Uganda, as I understand there are in Nigeria. So one of the first things that we had to support the system in multiple languages. People trading might not have wanted to trade in the same language. That was a challenge for them. When we interviewed people, we found that fewer than 10% of proposed trades actually completed. So automatic matching was really problematic because trades tended to unravel. And when we tried to understand why proposed trades weren't completing, one key issue was modeling. So sometimes trades that looked to us like they would be good trades would turn out not to be good trades because of transportation cost. Road distances that didn't look large to us might be across roads that weren't very passable. And reliability between buyers and sellers. So sometimes somebody would make a bid on the platform that they didn't really intend to honor, just to sort of put their foot in the water. Another key issue was timing. Farmers are highly liquidity constrained. And so sometimes they, if they couldn't get matched absolutely immediately, they would turn and sell to somebody else. Another problem is that it could be hard to repair solutions because a buyer might have a large truck that they want to fill up with produce along a route. And then if a couple of sellers pull out, then the buyer might not be viable anymore for the buyer to drive this large truck along a large distance. So our most recent pilot has been very labor intensive because we had to provide in-village support services. We had to run the call center that I showed you a picture of. We had to verify transactions over the phone. So, although the pilot showed that we were able to get a lot of people trading when we provided all of these services, it ran on a large grant from a bunch of American economists, and when their funding was exhausted, we weren't able to keep the pilot running. So since then, we've focused on ways of making this project more sustainable going forward. And we've given some thought to what a leaner version of Kudu might look like. And the approach that we've been pursuing is to replace deal coordinators. So we had these deal coordinators who would phone people up and sort of drill through this database to try to figure out what might work. And happily, in the time since we first built Kudu, smartphones have become more and more common in Uganda. They're still probably not very common among farmers, as I understand it, but I think they've become common in the cities. And so buyers, who would be the people who own or rent trucks and actually have the capital to go buy 13 tons of produce, would, I think at this point, typically have access to smartphones. So we think it makes sense for buyers to basically act as their own deal coordinators. So given that they don't have to work over a SMS or USSD interface, they could express richer preferences over location and quantity and price through a smartphone interface, and then phone sellers themselves and build up these bids. And we would accept asks from sellers via multiple channels, structured SMS, maybe just conversational SMS or WhatsApp, and maybe have a small call center that would just process these SMS asks directly. So we've built an Android application that could do this kind of virtual deal coordinator role on behalf of buyers themselves. So we begin by saying, which crops are you interested in? You could set up, essentially filters on price, quantity, and recency, and then you can see, on a map where asks exist. You can then drill in to see these asks, and eventually get to the point of phoning somebody up and asking whether they're interested in actually transacting with you. So we're at the stage of having built this open source app. We're having a kind of conversation with people in Uganda who are perhaps interested in deploying this thing, but it's been a long and twisting road, particularly because it's really important for a project like this, where a bunch of outsiders want to help some problem in a country that they don't live in. It's really important to have partners in that in that context who understand the problem better and who can pair up to make this thing a success. The graduate students we worked with in Uganda have graduated. Our partners are not as close to the problem as they were. So we're sort of at a point where we'd love to find new partners to work with if we want to keep this thing going forward. And it's still not clear that we've exactly found the right model of the problem, but we continue to hope that success is around the corner. So in the last little bit of time we have here, I want to step out and reflect on these two projects that I've told you about and try to think about what we can learn from this. So overall, AI technologies are really hard to develop. I mean, even if you have a straightforwardly stated problem, it can often be computationally intractable or even provably impossible to solve the problem. So we as AI scientists are trained to do lots of very clever work to address these really difficult to solve straightforwardly stated problems by approximating or reformulating or relaxing or finding heuristics that work in a limited domain, even if we're not able to solve the problem in all of its generality. And we have a research literature that focuses on conveying these kinds of clever ideas so that other people don't have to start from scratch. So, I represent a community of such AI researchers who have had an interest in trying to address social problems via these kinds of techniques. And what happens when we do that? Well, I guess let me claim there are a couple of different models of how things might go. The first model might be what I would call write a paper. So you get approached by a stakeholder with a good idea for how some research that you understand aligns with a social problem. And you probably don't initiate the project with them unless you see some kernel of an idea in some way that a technology that you know something about might make an impact on this problem. And you begin by trying to find a really clean way of stating the problem. And then once you have a clean version of the problem, you try to see if you can find a way of using the technology that you understand to make some headway on it. And if it's trivial, or if you find that it's addressed by existing work, then you might make it a little bit more complicated. If it seems too hard, you might simplify further. And you kind of try to fiddle around trying to find a problem that matches up well until you get some positive result. And at that point you say, it looks like we have something here. It looks like we have a paper. And then you sort of try to generalize as much as you can, understand the problem more deeply, until you get a sort of paper's worth of data. You hit the next paper deadline, and then you move on. And I guess I'll argue that the first problem that I spoke about, the food pantry problem, looked like this, where we were approached by people who understood a problem that food pantries really have. We abstracted it. We found a clean mathematical problem. We managed to do some new theory that it was interesting to theorists. We generalized and found various ways of making the model better approximate reality. And then we moved on. The second kind of model for how to have a social impact, I might call be an entrepreneur. And this might look more like the sorts of things you would do if you wanted to start a startup than the sorts of things you might do if you wanted to write a book. So this approach might take a lot longer. It might involve more rapid shifting around. It might never produce something that the academic community would be interested in. So it might look more like the kind of lean startup recipe where you do your best to understand the market, you prototype rapidly, you get lots of feedback from users to try to see whether they like the thing you're developing. If they don't seem to like it, then you pivot, you try to find something different that you can do. And you keep repeating this until you run out of funding or your team goes away or you have amazing success. And it's worth noticing that this is kind of the business school people tell us this is kind of the best recipe for how to make a startup. And even so, something like 90% of startups fail, even when they don't have to develop clever new technology, because it's just hard to guess right about what people's needs really are and which approaches will work. So focusing on addressing under-resourced communities and by developing new AI technologies doesn't make all of this easier, it makes it harder. So if we try to lock into a solution right at the beginning, we're less likely to be impactful in practice. If we focus on making a difference, we're more likely to drift away from the technologies that we really understand and the core expertise that we have about AI. So this is really tricky to do well. Obviously, what we would really like is what I might call project model number 3, which seeks to do all of the above. We want to do deep theory in AI and make a big difference in the world all at the same time. Now, there's kind of an unsatisfying approach that I think some work in our community does, where you do these two kind of in parallel with loose causal coupling between them. So, you're doing sort of a lean startup thing, you're making some kind of impact in the world, and then once in a while you throw off a paper that might not directly talk about the thing that you're actually doing in practice. And I think that's unsatisfying. That's not really what anyone wants to do, although maybe it's a good way to have a career. I think some of our field's most celebrated projects manage to get all of this stuff. They do number 1 and 2 in parallel with real causal connections, but it's hard to distill some of these successes into a recipe to really understand, did these projects get lucky or is there a secret sauce? Reflecting on projects that have impressed us the most, it seems to us that novelty in problem formulation is at least as important in novelty in technical solutions. So it seems to be really important to try to think about formulations that will move the needle rather than just applying a cool AI technology. Having the ability to communicate with and understand stakeholders is really key. And it's really important to have a partner who understands practical problems that really are technical. So typically technical people are good at solving hard technical problems, but they're not so good at understanding domains and knowing which practical problems are really technical, are really going to be worth using this technical expertise for. So, if you as data scientists really want to think about having a social impact with your work, I think finding ways to partner up with people who really understand problem domains, but also really understand data science well enough that you can have a technical conversation with them, I think that might be the single thing that best predicts your ability to have an impact going forward. It certainly has mattered to me. My last slide about this, how can we think about teaching and growing the community? How can we get computer science students to do good AI for social impact work? I think we might look at the way that business schools teach. they tend to use this kind of case-based reasoning to think about the way that enterprises face concrete challenges. And they tend to also sort of privilege experiential project-based learning, often built around these kinds of cases. If we want to claim that problem reformulation is really important, then we shouldn't just do projects where we dump students into a project, let them do the project, and then grade them at the end. But we should instead really have scaffolded learning experiences where the teacher is part of the problem reformulation piece, where we really try to help our students think about how reformulation works. And one provocative idea that I've gotten interested in is whether computer science and data science need our own kind of literature of cases where we can help our students to reason about previous social impact projects and ways that they both succeeded and failed, and where some key inflection points were for them in thinking about roadblocks. That's one reason why in this talk, I've wanted to be really transparent to you, both about some things that we got excited about in our own past work, but also places that I think we fell short, places where we struggled, because I think others can really learn from both the successes and failures of previous projects. And I think our literature tends to really tell a rosy story about what worked and not to be very brave about talking about failures. So in conclusion, I think if we want to encourage great work in our research community, we should seek out and develop partners at least as much as projects. We should look for innovation in the business model or the application strategy, at least as much as in the methodology. And that we should do that in our conferences. We should really reward innovation in strategy as well as in methodology by, for example, tracks like the AI for Social Impact track at AAAI that I'm involved in. I'm the program chair this year. And we should share best practices for process at least as much as for outcomes, because I think we get better at what we focus explicitly on and reward people for doing. So in conclusion, we might think about various different ways that AI researchers can impact society. They can do it by writing a paper. I told you about one project I was involved in around food banks that I think looks a bit like that. They can try to be an entrepreneur. I told you about a project in Uganda that was much more entrepreneurial. And we can dream about trying to have it all. Sometimes when we do, we miss the mark. There have been some occasional shining successes, and I think we need to work harder to try to understand what separates the two. But I think all of us are here because we believe that we have a moral obligation to do everything we can, that technologies are changing rapidly, and there are a lot of low-hanging fruit where we can use these transformative ideas to really make an impact in people's lives. So thanks for your attention, and I'd be happy to take some more questions. So let's see. Does the moderator want to step in and let me know what we should do? I see one question in the Q&A.
Yes, wonderful presentation. Thank you so much, Dr. Kevin. So it looks like we have two major questions just before we call it a day. There's a first question here that seems to be quite applicable to the Nigerian scenario. So this person says, this is Wasiu Solomon. It says, in Nigeria, a situation regarding looting of donated food, that is palliative, in warehouses occurred recently. How can we advise the government in distributing, allocating, and optimizing these food palliatives, considering the fact that the population of those who need the items exceed the quantity of the donated food?
So I couldn't make out everything you said, but let me say it back and make sure I got it right. So this is again a problem of donating food. So you have food kind of in central warehouses of some kind. Yes. You have much more demand than you have supply.
Exactly.
And there's a question about how to best make that allocation.
Yeah, exactly.
So, I mean, I think this is where the principles of market design are most applicable. I think you would want to think about market design in this kind of a setting. Anytime you have scarcity, you have a market in some sense. right? A lottery is also a market. It's one should just really try to think about what objectives the central authority has for making the donations. So I guess the missing ingredient that I don't understand here. This might be a conversation that'd be worth. If somebody really works in this domain, I might be interested in speaking further. But what is the central goal of the authority that has the food? I mean, what is it trying to achieve? Because if you say that there's much more demand than there is supply, I could say give it to anyone, give it to the first people who show up. If everyone needs it, then I can't go wrong, right? No matter how I give it out, I'm giving it out to people who need it. That's great. So I think things become tricky when some people need it more than others, and it's hard to figure out whose need is greater. In that kind of a case, that's where we really might want to think of the market, right? If I have a setting where there's lots of need and a little bit of supply, and it's sad that I can't meet all of the need, but so it goes, then I can't. It's a sad situation that I can't better meet people's needs, but the allocation problem isn't hard. But what can often be the case is, some people's need is moderate and some people's need is really acute. And I want to really address the acute need, but I have to do it under constraints. Like I want to make sure I don't completely wipe out the local shopkeepers by showing up with a bunch of free food and destroying the local economy. And I have to think about transportation, and I have to think about spoilage, and I have to make sure that people get the kinds of food they actually need. And this is a complex optimization problem that I don't have all the inputs to. So if I have this sort of really complex setting, then I really have to think about market design. Does that make sense?
Absolutely, absolutely. Thank you very much. That was a fantastic response. So for time, I think we should just take one last question. Okay, so let me look. Okay, so this person. Okay, so this question says, this is from Kamaldeen Adekola, says, great presentation, Professor. Okay, so it says, I would like to ask how you went on collecting the data of farmers in Uganda. Did your team have to travel to Uganda?
Yeah, so I mean, I guess I did this work when I was living in Uganda. So I spent half of the sabbatical living in Uganda. And we did travel around quite a bit. But also I worked with graduate students and professors who just lived all the time in Uganda and had grown up there and knew the community well. So partly we went around, we did some sort of site visits and saw things for ourselves, but partly we were just, our team consisted mostly of people in Uganda who understood life in Uganda. Yeah. And, I think that's really important. I think if I'd just come, if I'd been in Canada the entire time, just kind of based on my own impressions of Uganda, I would have gotten everything completely wrong, right? I think it's very hard to understand another society from the outside. I'm sure this is something that you guys are acutely aware of, as a data science Nigeria organization, seeing, often the rest of the world really wants to make a difference, particularly in Africa, but can just completely fail to understand local conditions. And I think a lot of aid just badly misses the mark, really just fails to recognize what the real needs are, how society works, what the problems are. And I think this is tricky. I think people want to make a difference, but they really need to understand to do so. So I think there's no silver bullet, but I think it's really necessary to physically see these things for yourself, but also to invest the time to get to know it better and to work with people who really do understand it.
Awesome. Thank you very much, Prof. Thank you so much. There's one more question, which I think you would love to answer. So this question says that, how best can people build models in areas of data insufficiency? Data insufficiency. How can we build models when?
Yeah, that's pretty tricky, right? I mean, I think we live in an era now where we know how to take a ton of data and build a model, right? If we have big data, we can take our kind of off-the-shelf machine learning approach and do pretty well. When we don't have enough data, what do we do? I think we need to sort of supplement whatever data we have with some kind of structural assumptions. So in a sense, that's something economics has been doing for a long time, right? We say something about let me talk to people who understand the setting and make some kind of structural assumptions about what people's preferences look like or how a system works, that I can build kind of a generative model based on these structural assumptions. And then I can fine tune this generative model with data. So I can try to build a combination of structural modeling and fine tuning with data to make up for the fact that I don't just have giant amounts of data. And it's probably not as good as having giant amounts of data, but it's better than just overfitting based on a tiny amount of data.
Awesome. Wow, it's been a very, very interesting session. Thank you so much, Dr. Kevin, for sharing so freely. We are so excited about this opportunity. Thank you very much. Okay, so for time, we've
Thanks again. I hope one of these days to see many of you in Nigeria.
Absolutely.
I would really love to come and see you all someday. And in the meantime, stay safe. We're watching and rooting for you as you guys go through the choppy times that you're in.
Yeah, thank you so much. Thank you so much. We really, really appreciate you. Okay, so we've come to the end of today's session. We'll meet again, attendees, tomorrow, 9 a.m. session tomorrow. So make sure to rest well. Have a good night rest. Thank you. Bye.